Okay, this is the video basically showing parallel connections. What I have here is the same four packs in the previous video, except they're in a parallel. They're in parallel. Parallel means to take all four of the packs, where you connect all the positive leads together and all the negative leads together to create one large big battery. The difference between series and parallel is series you're adding voltage, and parallel you're adding amp hours. So right now I have four 16.8 volts 20 amp hour packs, but when I put them in parallel, I now have one large 16.8 volt 80 amp hour pack. And so if basically what this means is, if I was running something like an inverter off of one of these, it would give me 1 hour of runtime. But if I have four of these in parallel, it gives me 4 hours of runtime. And the way that this translates to, vehicles is, the more amp hours you have, the more range you have. The more amp hours you have means you have more watt hours, therefore you have more range. And what you calculate your watt hours by multiplying your voltage times your amp hour. You can increase your watt hours by adding voltage, but you can also increase your watt hours by adding amp hours. And so by doing a parallel connection, you can by doing parallel connections with your batteries, if you want to stay at the same voltage and increase your range, you need to put more batteries in parallel, and that will help you increase your range. Now, when you put batteries in parallel, it doesn't increase voltage. The voltage stays the same, but like I said, the amp hour increases. So right now I'm using a 6-to-1 cable to parallel these four packs together. This is just for demonstration purposes. Do not use this cable to parallel your packs. You can either buy a cable from a custom-made cable from me or make your own, but do not use the pre-made cables that you can buy from vendors to parallel your packs to use on the road. The gauge wire is too small for you to pull any real amount of current, but right now this cable is basically paralleling all the positive leads and all the negative leads. Since I only have four packs, I have four connections down here, and there's two left unused. But however, I can check the voltage on these four packs through these spare leads right here. So I'm basically showing you that with all four of these packs in parallel, the voltage didn't change any, but the amp hours did increase by 4. So previous video these four packs were giving me 67 volts. With all of them in parallel, there's giving me 16.8 volts. So the voltage didn't change, the amp hour changed. And so another way to show you how paralleling works is, these four packs are basically four smaller packs made into one large pack. And if you can tell, like, I have 4 wires soldered to one large wire on the positive and the negative leads, and you can obviously see the 4 balance taps. So this one pack is 4 4S packs put in parallel, and each one of these packs were 5 amp hours. So 4 times 5 gives me 20. So this one pack is 20 amp hours, versus one of these packs alone by itself would be only 5 amp hours. Another reason why you would want to put packs in parallel is, let's say you had an application where you required a lot of amps. One pack could possibly supply the amount of amps that you need, but in order to make the pack and battery lasts longer, you want to put more cells in parallel to help that one pack out. So you would increase the battery's capacity by adding more batteries in parallel. So in this case, this 5 amp hour pack went to 20 amp hours. So since these are 20C cells, 5 times 20 is 100 amps. So one of these packs could deliver 100 amps by itself, but with 4 in parallel, this whole battery could give a potential of 400 amps. So if you had like a motorcycle or something that required 150, 200 amps, one pack wouldn't be able to do it. But if you put 2, 3, or 4 in parallel, it will give it the capability that it will give it the current, it will give the motorcycle the current that it needs to propel you properly. So that's another reason why you would parallel packs. Okay, another reason why you want to parallel packs is for charging. The more expensive chargers that charge at pack voltage gets very expensive. So the only alternative to charge a lot of batteries at once is to parallel charge. And that basically means you take all of your packs and you put them in parallel to where it creates one large big battery, and it's at a voltage that your charger can charge at. There are some chargers that can charge up to 14S, but you start spending a lot of money once you start looking at those type of chargers. The iCharger 36B is a charger that can charge 6S packs at up to 30 amps. So 6S is basically 22.2 volts. But let's say if you had an 88 volt pack, this charger wouldn't be able to charge an 88 volt pack. But if you split that pack up into 4 22.2 volt sections, this charger can charge all of those 4 sections in parallel at 22.2 volts. When parallel charging, yes, you will have to break your series connections and manually parallel all your batteries together, but this allows you to use a regular RC charger to charge all your batteries versus buying an expensive bulk charger from like BMS battery that's going to cost, a decent amount of money and a lot to ship. And you can accomplish the same thing with a less powerful but just as capable charger. Just because this charger is at a lower voltage doesn't mean you can't charge your full battery pack. If you just put the sections of your battery pack in parallel, you can charge them all at once on one of these chargers. Like I said, this one can put out 30 amps. For my large pack, I have a 2 kilowatt hour pack. It'll take me about 4 hours at 30 amps to charge, all my batteries at once. But this one has so many more features, and it is slightly more complicated to charge in parallel. But once you do it a few times, you can make the change in like less than a minute to charge in parallel. But bulk charging, you just unplug your discharge cable, plug in your charge cable, and you're ready to go. Parallel charging, you got to disconnect multiple sections. In my case, I will have a total of 6 packs that I have to disconnect and put in parallel to charge on my iCharger. But then again, like I said, this is a very capable charger. It can put out 30 amps. 30 amps, which is about 500 watts. But it can balance. It can charge other chemistries. It can discharge and everything. So I wouldn't put all of my eggs in one basket with a big bolt charger. They do seem nice for opportunity charging and everything, but you know, if I had to make one purchase, you know, a bulk charger versus an RC balancing charger, I would go with the RC balancing charger every time for charging. And like I said, that's another reason why we parallel packs is for